Okay, so I want to go through another example from what we did yesterday on 4 or 5. When they say find all the roots, okay, this is our beginning equation. X to the 4th minus 7x cubed plus 17x squared minus x minus 26, and set that equal to 0. Okay. What you ought to do first is the Descartes rule of signs, okay, like we did yesterday, and that's good. Go back and review it anyway, okay. And you don't know how many rows you need, but it's always positive, negative, 0, and imaginary. Okay, and remember, to get the positive, to get this box, you look for variations in sign. Okay, so this goes from a positive to a negative, that's 1. Negative to a positive, that's 2. Positive to a negative, that's 3. And negative to a negative, so I get 3. You agree with that? Okay. To get the negative box, everywhere you see an x, you put in a negative x. So a negative to the 4th would be positive. Negative cubed, negative times a negative 7, positive. A negative squared, positive times a positive, still be positive. Negative times a negative, positive, and then the negative stays the same. So variations in sign, there'd be 1. Okay, and this row across, remember, has to add up to your highest exponent, and there's no 0 roots because there's nothing in common, and it has to add up to 4, so the imaginaries would be 0. If either one of these, the positive or the negative, is 2 or greater, you can depress it by an even number. So this one is 2 or greater, so I can subtract 2 from it each time. So subtract 2 would make that a 1. If this is a 1, it's going to stay a 1. So that means the imaginaries has to go up. The other thing to remember is this column on the imaginaries will always be even, like 0, 2, 4, 6, because they always occur in conjugate pairs. You won't ever have an odd number in that column. Okay, so we don't know which case it is. It might be 3 positive roots and 1 negative. It might be, and no imaginaries, might be 1 positive, 1 negative, and 2 imaginaries. We don't know. Okay? Now we do the rational root theorem. The rational root theorem says factors of p divided by factors of q. So you want all the numbers, p over q. You want all the numbers that are factors of 26, like positive or negative 1, positive or negative 2, positive or negative 13, and positive or negative 26. Now, you're not guaranteed that any of those are roots, but if there are any rational roots, they've got to come from that list. Okay? Now, I'm not taking the calculator away. Normally, you'd have to do synthetic division, and test all those. Okay? Take the calculator, graph your graph, and just see if you can tell one of those roots, and that's the one I would do by synthetic. Okay? So let's put in that x to the 4th minus 7x cubed plus 17x squared minus x minus 26. Okay, and let's look at the graph. I'm going to do zoom 6 to start. Okay, we're not seeing the whole graph, we don't need all the on the left and the right, so let's change our window. Let's go -5 to 5, scale 1. Let's go down farther. Let's go negative. Let's see. Let's go like -30 down. And I don't need this tick mark, so I'm setting the x. Let's see if that works. Yep, that'll give us the whole graph. Okay, so the window I'm using is -5 to 5, scale 1. The y I'm using is -30 to 10, and I just turned the tick marks off. Okay. because what I really want to look at is the zeros where it crosses. Okay, so now you can look at your graph, okay, and it looks like on your graph, and it's an x to the fourth. An x to the fourth is usually going to be like an x squared, okay, and even, and this number in front is positive, so it opens up. Okay, so it looks like, so it looks like on this one, like that's -1. So that starts it. Okay, so let's use -1. Okay, because when you're doing the homework, you don't have the whole class to help you do the synthetic, so use the calculator to help. Okay, so do 1, -7. Remember on synthetic, if they leave out a term, you have to put in the 0. Okay, and do -1. So add going down, and then multiply. Add going down, and multiply. Add going down, and multiply. Add going down. Oops, add going down. -26 and add 26 be 0. Okay? Okay? Everybody good with that? Okay, so this is one negative root. Now you go back at this, we have found the one negative root. Okay? It would be a waste of time to test any other negative roots because there aren't any. Okay? So now we test positive, but you look at your graph, where else does it look like it's crossing? 2. Now, here's what the emphasis on the, I know I said it yesterday, but we didn't do an example like it. Don't ever go back to this top row. You always work with the depressed row. And the reason is, if you don't work with the depressed row and get down to the x squared row, you won't ever get the irrationals, you won't ever get the imaginaries. Okay? Okay, so work with this bottom row. So now we're going to do 2, and just write it right there. Just keep going. Okay, so add going down, multiply, add going down, multiply, and that would be 26 and 0. Okay? Okay, so this is also a root. Okay? So right now we have one negative root and one positive root. We're for sure, we've got, and we don't know about the which, but that we found one positive, one negative. But here's the good thing. This was an x to the fourth row. So now this row is an x to the third row. Now this row is the x squared row. That row you can solve. Okay? You can solve definitely by quadratic formula, not always by factoring. Okay, so I would probably go quadratic formula. So you have this would be x squared minus 6x plus 13 equals 0. You could look at that and say, okay, do I have two numbers that multiply together to give me 13 and add together to give me 6? No. Okay, so figure out what's the A, what's the B, what's the C. Okay, and then go to the quadratic formula. X equals, write the formula down, opposite of B, plus or minus the square root of B squared minus 4AC, and it's all over 2A. Extend that radical out, and make sure you write the left side. Don't leave off the X equals. Okay? Okay, now sub in. And it's the opposite of a -6, plus or minus the square root of -6 squared minus 4. A is 1, C is 13, and it's all over 2 times 1. You agree with that, subbing in? Okay, so this would be x equals 6 plus or minus, that'd be 36, and what, is that 52? Negative 52? You agree with that? All over 2? Okay, so 52 and 36, 16, be negative 16 inside. You agree with that? So x equals 6 plus or minus negative 16 all over 2. And then I usually split that up and say 6 plus or minus. I usually do a lot of times that helps. Out of Out of this, I can take out a 4. Out of this, I can take out an I. So plus or minus 4i all over 2. That 2, that's a polynomial over a monomial. That 2 divides into both of them. So x equals 3. A lot of times people do this, and you got to be careful. A lot of times people do, oh, and my answer is 3 plus or minus 4i. No, that 2 divides into both of them. You got to be careful when that's a polynomial over a monomial, so it goes into both of them. So you'd have 3 plus or minus 2i. Okay. So if you go back on the, we have 2 imaginary answers, and 1 positive and 1 negative. So this was actually this case. Okay. Okay. This is an answer. This is an answer. X equals -1. X equals 2. And x equals 3 plus or minus 2i. Okay? And that's what I mean by always work with that depressed row. You always work with this bottom row. Don't ever go back to the original. Because if you go back to the original, you won't ever get down to an x squared row. And you've got to get there. Okay? Okay, so on these, you start out with the Cauchy signs, then the rational root theorem, graph it, see where it crosses the x-axis. That gets you started on synthetic. Okay? Any questions on that problem? Okay. Give you time to work.